Okay. We'll see. I'm not a big pop quiz guy. Like, I just don't typically do it. If we do wind up having a pop quiz this hour, it will not burn you, I promise. Okay, we'll see how we feel. All right, so last little bit of 2.4. I should have looked. What's the very last thing you guys had from 2.4 in your notes? Probably quotient and product rule examples. Or maybe a physics example. Okay, so last little pieces. As we're looking, the very, very culmination of 2.4. Here we go, higher order derivatives. Now, immediately, since we looked at that physics one last, and even if it's not fresh in your head, what we connected at the very end of class last time was that if you give me position and you take its derivative, you differentiate it. You go from position to a change in position over time, and you get velocity. But you could differentiate it again and take the change in velocity, and you would wind up with acceleration. Whether I say the derivative of velocity is acceleration, or if I said the second, like two derivatives away from position, it's the same thing, right? We just differentiated twice. When we talk about higher order derivatives, all we're looking at is the derivative of a derivative however many times. So we'll just go ahead in a really quick, easy, it's not really a vocab, but we need to make sure we get it. Higher order derivatives are just multiple differentiations. Okay. Now, you guys, we don't really get to see it in here, but do you remember back in Algebra 2 finding, or even pre-calc, finding arithmetic and geometric sequences, where I gave us a number like 1, 3, 5, 7, the next number is 9, and then 11, and so forth, and we said, hey, determine if this is arithmetic or not. It can be really hard to do that sometimes, and it turns out that something here relates to it. And maybe we'll get to see a glimpse of it, maybe we won't, but there is some math connecting back to things that you've seen that fit into other places rather than just a traditional approach to calculus. Okay, so multiple differentiations. All that this means is we typically, and we're just going to write a few of them, we're going to talk first about the ones that we've seen. We've talked quite a bit about first derivatives. And we never even mentioned that they're the first derivative. We just call it the derivative. First derivatives. They're everything that we've been doing so far. And I just want to cover a few of the notations. If we have a function y, what's its derivative? Y prime. And we're just looking at notation right now. What if we have a function f? What's its derivative? F prime. Good. I'm cool with that. This one, they're the same thing, just not prime. We could do dy dx. That's that first one. These two link. Or we could do d dx of the argument of that derivative could be considered to be f of x. These all mean the same thing. 4 different ways to write the first derivative of a function, whether it's y or f, y prime or dy dx, and f prime. And you could write df of x dx, but it looks ugly. So it makes more sense, in my mind at least, to say d dx of this is what we're taking the derivative of, with the understanding that they're both accepted. Okay. Now we're going to branch out. I'm going to switch color for every single one of them. Weird. If we have a first derivative, well then naturally we could possibly and conceivably talk about second derivatives. If you got to write the rules instead of y prime, any suggestions? And you might have seen this in geometry, but I didn't teach you geometry, so I'm not sure. Like, do you guys remember doing transformations in geometry where you rotate it and then translate it? The first rotation, if it was point A translated, or wrote whatever it did, A moved and you called it A prime. Do you remember what you called the next move? Double prime. Okay, Y or A prime prime. We won't say prime prime. Why double prime? Right here. Now I'm going to put, that's misleading because it looks the same. We'll just do it. Double prime. Okay, Y double prime. Second derivative. Similarly, instead of f prime, what do you think we could call it? F double prime. Now, they do get a little uglier here. These ones, it's super strange the way that this works out. We are not in a differential equations class. We're not doing analysis to prove all this. So I hate to say it, but we're just going to accept the notation. Okay, if we want the second derivative here, it is d squared y. over dx squared. Second derivative, notice the 2 here. Or we could do d squared dx squared of f of x, just like we had seen the other ones. Okay, so if we think in the physics piece, if we have some function that starts here, s, my position, we take the first derivative, we wound up at velocity. We take the derivative again, and we wound up where? Acceleration. S double prime is how we would say that, or v prime. They're the same function, it just depends on where we started. I'm not going to do this for a bunch of them. Can we imagine, and we'll do 2 more, at least in general. We'll do 1 more solid one, and then we'll look. Can we do a third derivative, you think? I don't know that I need to write all of them. I'm only going to do the prime notation. Sean, shot in the dark, what do you think we're going to say is the third derivative of y? Y triple prime is indeed correct, and f triple prime would be correct. Do you want the d cubed y dx cubed? I guess if you want it, entirely up to you. D cubed y dx cubed, or d cubed dx cubed of f. Okay, you do not have to use all these. If I'm doing anything bigger than a first derivative, there's a 100% chance that I'm going to use the prime notation. Very seldomly do I actually default to the differential notation that we see here, but it exists. Now, we could just keep going, right? Like, and this list will literally never stop. If I get any bigger than 3, I'm just going to say ... We're just going to call this the nth derivative. So I don't need to say the 4th, the 5th, doesn't matter. The nth derivative. And eventually, most functions, not all of them, but all of our polynomial functions will eventually run out of steps to do because you get down to 0 eventually. But for this, I kind of honestly think that triple prime looks stupid. Like, realistically, I just think it's ugly. I think it's not very nice to deal with. But I'm definitely not going to write quadruple prime or quintuple prime. Not going to happen. If we need an nth derivative bigger than 3, the standard notation is to use parentheses as an exponent. And if we're looking for the nth derivative, we just say y and then in parentheses the n. This is the nth derivative, and there's not a great way to write it. They're pretty rare that you would have to go up to a 4th derivative ever. So there is ambiguity, obviously, with just powers of y, but the parentheses are there to dictate that's not it. Similarly, f to the n of x is how we would write that nth derivative. I'm not going to write the other 2 because we won't see them. Okay, so here's one example, and I think I kind of want you guys to do it, but I'm all for democracy. Speaking of elections tomorrow, if you're 18, I don't know, anybody in here 18 right now? She gone. Riley, if you're watching this video, you should call the courthouse and see if you can get absentee vote somehow. I kind of doubt it for municipal election, but okay. All right. If you are 18 and nobody spoke up just now, you should go register to vote today and go vote for school board. I'm sure there's other vote stuff too, but I care about school board. All right. Here we go. I want you guys to find, so given, rather, ooh. Yep, we're doing this one. Given f of t is equal to, we'll make it nice for you, 1 plus t squared times e to the t. I want you guys to find f double prime of t. And here is our classroom democracy. Are we doing this together as a class, or you guys together in small groups and we'll come back together as a large unit? Class is what I just heard. I'm fine with it. Okay. If I want the second derivative, there's something I have to get first. The first derivative. So let's check it out and we'll see where we want to clean up as we go through the problem. But let's get it. Step 1, if we want double prime, we need prime. So let's do that. F prime of t. Options, options, options. Now, not really. I would use product rule right off the bat. Somebody may be looking and think that it's easier if you just distribute it. But if you distribute it, the product rule from the get-go. What's the first function? Okay, so don't touch it. It stays the same. 1 plus t squared times, what's the derivative of e to the t? E to the t. So first times the derivative of the second plus the second, and this is going to look different. Somebody, Aisha, I think it was, I called out for doing this differently than I do. In the end, maybe we're not going to, because now it's the second times the derivative of the first. Now, I do a little thinking. Here's a second. And notice that I left an awkward gap. Why? Too many answers at once. What do you guys think? Why would I leave an awkward gap here? Because I know that the derivative of this thing is 2t, and I'm crazy when it comes to how I write stuff. This looks natural to me. This, if we had done it like this, looks less natural. And I don't know why. If there's a coefficient that's going to come out, it's going to go to the front for me every time. Okay. If you don't like that, I can try not to. First times the derivative of the second plus the second times the derivative of the first. This is probably what you would have. Now, decisions. We have f prime. Could we differentiate it again right now? We could. Here's my concern, not really concern, but my apprehension. If I decided to differentiate it again right now, that first part has a product rule, and the second part has a product rule. So now I'd have to do 2 additional product rules, right? Like, blah. Or we spend 5 to 10 seconds and we clean it up first. Is there any obvious algebra that we could use to clean up and get a nicer version of f prime so that when we do another derivative, it's easier? Take out an e to the t, and it leaves behind, I'm going to rearrange it, t squared plus 2t plus 1. Now, still not like perfect, but I think we can probably all agree that it's much nicer to differentiate this single product rule than it is to do 2 of them. Cool. I want you guys, I'm going to pause it now. I want you to find me the second derivative. So all that is f prime. We're now going to sneak forward to f double prime. And if you're watching this video on the road, go ahead and pause it now and resume. You will see the worked out second derivative in 3, 2, 1.